Hi, I'm Deepak from Reliant Institute of Oil and Gas. So today we are going to see penetrant testing theoretical class 2. So in last class we have discussed some basic things about penetrant testing, and in today's class we are going to discuss the different color dyes mixed in the penetrant, then types of penetrant, and based on that what are the color dyes they are mixing, then different types of indications, then technical aspects, what are the difficulties in penetrant testing, then basic principle of penetrant testing. That is a very important thing. So even if you are going to an interview, so you will be asked, the first thing is the working principle or basic principle of penetrant testing, then PT procedure, penetrant testing procedure, then different penetrant removal techniques. Then we are also using a chemical called emulsifier, in specifically a special technique called post emulsification technique. So we are going to discuss about emulsifier, its function, then types of emulsifier, then how we are applying the penetrant on the surface. Different methodology is there to apply the penetrant. So all this we are going to discuss today's class. So the first thing is the penetrant type. Basically, in last class I have discussed that two basic method. One is visible technique and fluorescent technique, which is in dark room with the help of UV light or black light. We used to identify the indication. So in this, the penetrant type based on visible, fluorescent, another thing is there called dual sensitive. So this dual sensitive penetrant, which can be used for both visible technique and fluorescent technique. So in the case of visible, which is in a Courtson standard, we mention it as type 2 method. Type 2 method is visible method. In that penetrant, usual color is red color. So the solvent based will be a blood red and water based will be a light pinkish red. Then these indications can be identified with the help of white light or daylight. Then in the fluorescent method, fluorescent penetrant, which is type 1 penetrant, the color mixed is fluorescent green, and the indications will be green or yellowish green color when the UV light is focused over the area. So it will give a bright green indication, which I have given an example pictures in a previous class. Then in a dual sensitive will be orange, the fluorescent orange, which is very visible in normal white light or daylight, also will be visible in with the help of UV light we can able to identify very clearly. Then testing temperature is very important when you are going for an interview. So the testing temperature for penetrant testing is 5 degrees Celsius to 52 degrees Celsius. This is in the case of American standard ASME, and in the case of ISO BS EN 9712, so it will come around, like in PCN they talk about 5 to 60 degrees. So only the small differences. In a Courtson standard, especially in American standard, it is up to 52. In British standard or ISO, they go for 60. So in normal case, below 5 degree, the penetrant is basically an oil. So it will get thickened, get more thicker, density increases, so it affects the capillarity or capillary action. So we will not get any indication. In other case, above 60 degree. So when you are doing the testing in a hot desert, wilderness, or very hot area, so in a direct sunlight is falling upon the test object. So in that cases should know how much temperature atmospheric or ambient temperature is. If the ambient temperature goes beyond or up to 60, when it is 60 or above 50 degree itself, so the penetrant start to dry out. So we have to give very less dwell time. So between 5 to 60 degree, the dwell time is usual 5 to 10 minutes. So in the case of higher temperature, reduce the dwell time, or else it will dry out and there will not be any indication, only stain will be there, that the color will be there. So the lighting is very important in the case of liquid penetrant testing or penetrant testing or dye penetrant testing, or in some documentation it will be mentioned as dye penetrant inspection, especially in the case of PCN or British Standard based documents. So when we are using whether daylight or white light visible technique, visible penetrant, so in a field open space up to 377. So but actually, in some cases we should know that, in this case 350 to 500 lux required. 350 to 500 lux as per British Standard. I can also mention the code, that is EN 17637, then ASME section 5, then even in ISO. So this is a basic thing in the field. So if it is in a dull area or dark area or within the workshop or inside a plant, in-plant inspection, so in that case we need more than 1000 lux. Standard says precisely 1076, but usually 1000 to 2000 lux is more sufficient to conduct visible technique of penetrant testing. In the case of darkroom inspection or fluorescent method, in a dark area this is very sufficient. So you may be wondering that, so the white light in a dark region we need more, in a brighter area we need less. But in the case of black light, darker region we need less, little brighter area we need more, at least 3000 microwatt per centimeter square. So how do we determine or measure the white light or daylight intensity? With the help of lux meter. So this is the lux meter we use in Reliant while conducting the visible technique penetrant testing lab. So usually there will be a sensor. This is a sensor. So you have to switch on this. Automatically this equipment will be having a calibration certificate. Yearly once we have to calibrate, unless it will not give a proper reading. So we may be misguided or misled. So we have to open the sensor and we have to check where the inspection is conducted. On the specimen we have to keep the sensor and we have to check how much lighting is falling on the test object. So if you on, so some amount of lux will be there, and here 2000 lux, 20,000 lux, up to 50,000 lux it will show the value. So we have to put it like up to 2000 lux, and on it then it will show how much lux. So minimum 300 to 500 in open space, then in plant or in the lab we need more than 1000, or at least more than 600 is required, minimum requirement. So types of indication, when we conduct the testing, many indications will be obtained, but how do we know these indications are defects, these indications are not defect, or these kind of indication due to our mistake or technician mistake? So the false indication, when you are not removing the penetrant, excess penetrant properly, so those areas will be, the penetrant will be on the surface like a film, thin film, but you did not notice to clean it. So in that case, after you apply a developer, it will appear like a defect, but those are all due to you can see here, due to an inadequate removal of penetrant, rinsing, contamination, or even in your hand any contamination is there, that will lead to wrong decision, like false indication will come. So when I be in a site, when I am witnessing the penetrant testing in the site, especially wherever it is, a pipeline project or tank storage or even shipyard, structural, anywhere, wherever we conduct penetrant testing, if you find more false indication, so we should go for retest. So we should not accept the report. Instead we have to assist the or advise the technician to conduct retest on the part. So non-relevant indication, so the weld corners of the weld, any cut mark, punch or any hot stamps, so those are also will be shown, or even grinding marks sometimes shows even corroded region will show like a indication. So those are all we should not take, because that is non-relevant indication. So relevant indication is exactly a clean white background and blood red indication. So if you want to know these things, so we have already done lab practicals, NDT lab practicals. You can contact us, or it is also in YouTube, Reliant YouTube, so you can see those and try to see how we are conducted the penetrant testing visible technique. So you will be able to know or understand what I'm saying now. So relevant, non-relevant and false indications are there. So now you can see I have given an example here. See, this is a crack and this is a relevant indication, okay, and all these are false indication. Okay, any sharp edges, small dents, so those are all will be non-relevant indication. For example, here porosity or crack is there, so here the porosity is there, so these are all an indication, these are all non-relevant. Okay, so basic principle of penetrant testing. So what is the basic principle of penetrant testing? So the penetrant testing works on the thing called capillary action. So what is capillary action? The capillary action is a property of a liquid, so which it can be drawn, or it is entering into a very small opening. So when there is a very small opening, the liquid has a property or ability to enter into it, automatically rises into the capillary opening or capillarity tube. Capillary tubes are there, small openings are there. So a best example I can give that in olden days, like in 80s, we use fountain pen, ink pen, or we used to call hero pen. When there is a ink drop, when you take the nib, fountain pen nib near to that liquid, automatically we can see that the ink is drawn into the nib. So we think that the nib is sucking the ink. It's not like that. Due to the capillary action, the ink is able to enter the small fine opening of that nib, or that the pen. So that's called the capillary action. So that is why the capillary action does not depend on gravity. So even there is a different welding position. So we have 1G position, fillet position, 1G groove position, butt weld position like 1G, 2G, 3G, 4G, even in 6G, or the overhead position, overhead fillet position in a shipyard. So in structural welding, above the head, we call it as an overhead position. Even in that overhead welds, you can conduct PT, penetrant testing, because the penetrant will penetrate due to the capillary action into the overhead welds if it is having a open surface, crack. So you can see here I have given an example. So this tube explains the capillarity or capillary action of a liquid. So you can see a blue colored liquid here in one tube, and the different capillary tubes having a different diameter of opening. Okay, ID is different, and more thin. You can see the last tube, the liquid has risen more. So that is because of more capillary action has happened when the opening is less. More lesser the opening, more effectively the capillary action will take place. So that is why in a fine opening surface crack, the penetrant could able to penetrate into that, and we can able to get the indication. So the core principle of capillary action, where the liquid, the penetrant, rises or migrates into a narrow space like crack, pore due to the surface tension or adhesive property. So simply due to the capillary action. So the capillary action does not depend on gravity, so the penetrant testing can be conducted on overhead welding. So factors affecting the capillary action. So what are the factors affecting the capillary action? So first, the surface cleanliness. More, the surface cleaning or pre-cleaning is very important. So more you clean, more probability of getting an indication. Then the crack or the cavity should be clear based on the configuration, based on the cleanliness, size of the opening, the capillarity or capillary action can be affected. Then the ability of the liquid to wet the surface based on the penetrant property. So we call it as a surface tension. So if the surface tension is more, if the surface tension is more, so it can wet or it can stick to the surface, it can spread over the surface, the wettability will be high, then that also leads to effectively for the capillary action to happen. Even the contact angle of the liquid. So when you put a drop of a liquid and you zoom it and draw a tangential line, so it should be less than 20 degree, then the liquid can able to wet the surface very easily. So viscosity. Viscosity is something like resistance, liquid's resistance to flow, how much resistance it faces when it is trying to flow. So lower the viscosity, higher the penetration of the penetrant into the cavity or into the defect. So always remember one thing, the viscosity and capillary action is closely related. So higher the viscosity, lower the capillary action, lower the viscosity, higher the capillary action. So if you can see that penetrant testing relies on the property called viscosity, the dwell time, and even the surface tension. So how much time you are giving the penetrant, you are allowing the penetrant to stay on the surface, we call it as a dwell time. So it is a time required for the penetrant to completely penetrate into the defect and dwell or held in the defect, so that we can remove the excess penetrant from the surface later when we apply the developer. The developer, due to the reverse capillary action, it sucks the penetrant from the cavity, and since the oil has a color dye, it gives an indication we could able to locate the defect. So surface tension, it is a property of a liquid. How the adherence property. Adherence means how much it is sticking like a glue to the surface. So example we can give that needle floating on the water. So the surface tension depends on that. The needle is not entering into the water, it still floats there. So the surface tension versus capillary action. So it is very important that more surface tension can influence more penetration. That means the capillary action will be very effective. So contact angle. So I'll show directly the picture. So this is the liquid. So when you draw a tangential line, this angle is called as a contact angle. So usually the penetrant will be having a contact angle below 18 degree. So it can able to wet the surface, easily penetrate. Then DPI, dye penetrant inspection procedure. So the first thing is pre-cleaning, then we have to apply the penetrant, then we have to wait until the penetrant penetrates. So practically 5 to 10 minutes, we call it as a dwell time or dwell period. Then removal of excess penetrant from the surface, then we apply developer, then it takes time to develop the indication, then we have to do the inspection. So when we talk about inspection, testing plus evaluation, so we get the indication visibly, the visual, with the help of our eye, we able to see what type of indication, we justify that, and then we evaluate whether to accept, repair or reject. So with that, inspection concludes, and then we have to do the reporting, and after that finally we have to conduct post cleaning and return the piece to the client. So this is what we do. So first, the contamination, dirt, dust, or all has to be removed. Then we have that, we call it as a pre-cleaning. Then it will be open, the surface of the crack will be open like this. Then we apply the penetrant by the spraying technique. Then after the dwell time, we remove, here in this picture you can see we are removing the excessive penetrant from the surface. Then we apply developer. Then with the help of visual testing, we find out the indication and do other documentation. So in penetrant testing method, we have different method like method A, method B, method C, method D. So usually in other places they usually say like solvent removable, water washable, post emulsifiable. But as per the standard ASME section 5, we are dividing the third one into two types. So like method A for water washable, method B for post emulsification lipophilic type of emulsifier. Then method C, solvent removable, which is very commonly, we have already done it in the YouTube. Then hydrophilic water based emulsifier used for the post emulsification technique. Then the post emulsification technique is a two-step process to remove the excess penetrant, while in the water washable penetrant itself contain self emulsifying agent, so easily can be removed by rinsing in water. Okay. So you can see, I have picturized this. So water washable technique, with the help of water we remove, then developing agent, indication, post emulsifying, after the dwell time we apply emulsifier. The emulsifier converts the solvent based penetrant into water washable from the surface, then easily removed by rinsing in water. Then developing agent is applied, indication will be obtained. So this post emulsifiable method is more sensitive when compared to water washable and solvent removable technique. So as I said before, the emulsifier is rendering or converts the solvent removable penetrant into water washable. So we have two type of emulsifier, lipophilic and hydrophilic. Lipo means fat, so oil based emulsifier. Hydro means water, so water based emulsifier. So once we apply the emulsifier, we have to wait for a time which is called as a emulsification time, rendering time. So finally we are about to discuss about application of penetrant. So we can apply the penetrant over the surface with the help like spraying method or spraying technique, brushing, dipping and flooding. So 4 techniques are there. So you can see here the technician or inspector is conducting it with the help of spraying method, spraying technique. Then this is only a particular area we need, so brushing technique. Then this is dipping technique. Mostly in fluorescent method we dip the product in the penetrant tank, then after the dwell period we lift it and then we rinse it with the water, and then we conduct the testing. Then flooding, with a hose pipe we apply the penetrant for a larger surface or large sized product. So this concludes the part 2, and in the next part I'll be discussing further. So almost in the part 3 the liquid penetrant testing will be concluded completely. And after part 3 you watched the 3 parts completely, then don't forget to see the practical session we have already uploaded. So after part 3 we'll be going with the next NDT method. Thank you.